So Ms. Brock, the teacher I had, or I kept saying every time we had this, I kept saying sins instead of sine. They got so mad at me.
I can understand that.
Well, I kept saying sine, I always remembered the sin. So it's like,
Yeah,
so now
'cause
we're
it
doing
looks like
sin
sin.
because we're Satan worshipers at that point. So.
Yeah, this will not be a godly law. This is just the mathematical law. All right, so Tuesday, we worked with two theorems that allowed us to solve right triangles. Okay, so we had Pythagorean's theorem and we had our ratios, trig ratios. Okay, well today we're going to talk about one way to solve oblique triangles. Okay, so everybody know what the word oblique means?
No.
Right. Ha, wrong. Not right. Okay, so we're working with triangles that do not have right angles. Okay. The first part of this kind of takes you through using the area formula to find the law of sines. We might go back and look at that later, but for right now, I'm just going to give you the law of sines. Okay. So the piece that you need to write down in your notes is definitely the law of sines is this scenario. If you want to draw a pretty picture of an oblique triangle, you can, although it's probably not necessary. You guys did this before?
I think we touched it. Like, slightly remember it.
Oh. This is probably the first time I've ever taught this one. You guys have seen it before.
Yeah, because I remember, again, it's back in the scroll. I just remember making the connection of B to B, C to C, is able to diagonal lines.
Oh. Right, yeah. Okay. So that's a good point to make, is that I did say this in the last section, but in case you didn't hear me say it, do realize that when we're working with triangles, that if I'm working with angle A, side A is always going to be opposite of that. Okay, so the way this triangle is labeled, that's an important way to understand that. So now that you have this written down, what do you notice about these ratios? Okay, they're equaling each other. What?
They're all in the sine.
Okay, like the sines are in the top of all the ratios, right? So you have the sine of the angle over the length of the side. Okay, did you hear me say that? The sine of the angle over the length of the side. And notice that with one fraction, you have like the A's, and then the next fraction is the B's, and the next one is the C's. Okay, so it's important for you to note that you can only use a law of sines if you have an angle and its opposite. I would write that down. Okay, so you can only use this if you have an angle and its opposite. Okay, so if you have both the A's, you can use the law of sines. If you have both the B's, you can use the law of sines. If you have both the C's, you can use the law of sines. Right. Everybody got that written down? Example. Hold on. Let's use this little picture right here. All right, so we're doing the exact same thing as what we were doing in the last section. We are just solving triangles. Okay, so this scenario, we have this beautiful oblique triangle. Okay, so let's say they ask us to Solve it. Solve. So find all the missing pieces. What would you do? Okay, so if we start in on the law of sines, what angle and its opposite do we have?
R.
The r's. Okay, so that is the first ratio that we're going to set up. Okay, so I have the sine of 35 over the length of its side, which is 15. All right, at this point I only have one other piece of information on the triangle. I have a 38-degree angle. So what other ratio am I going to set up? The s's. Okay, so we're gonna set this equal to the s's. So we're gonna have the sine of the angle s over the side of s, which we do not know. Make sure you draw a really curly s because s's look like 5s in math.
Yeah.
That's like the prettiest S I've ever drawn in my life. All right, so how would you solve that equation? I've got a proportion. How do you solve proportions? What? You cross multiply. So what two things are we going to multiply times each other? 15. So we're going to have 15 times the sine of 38. And what's that going to be equal to?
9.2.
Okay, hold on. Before we put it into the calculator, what's that equal to? What's the other cross multiplication? S times the sine of 35. So before I even use my calculator, how do I solve for S on my next step? Not subtract, divide. There you go. So we're going to divide it. So we're going to type in 15 times the sine of 38 divided by the sine of 35.
Okay, 16.
16? Does everybody agree with that? Okay, so that sounds like a yes. Oh, you didn't already? Okay, how can we find? What else can we do? Ooh, okay, now say that again, Tyler. Can we use Pythagorean's theorem?
No.
We cannot use Pythagorean's theorem. Why can we not use Pythagorean's theorem? It's not a right triangle. Okay, so you can't go there. Pythagorean's theorem is not an option. What can we do?
180 minus 3.
Ah, right, we got two angles. Okay, if we got two angles, we can find the third by just doing 180 minus the other two. So t will be 180 minus 35 minus 38. Anybody get that? 107 degrees. Okay. So the last piece I'm missing is side t. How do I find side t? What do I have to do? What's my only option at this point? I have to use nope, can't do SOHCAHTOA because that's for a right triangle. I only can use a law of sine. That's my only option right now. That's all you guys know. So I have to do a law of sine. So what was the angle in the side that we knew? The r's. I always start with the given information. So I'm going to start with the sine of 35 over 15 with the r's. And now I'm looking for my side t. So it's going to be the sine.
Wait, why can't we use the
You technically can. The reason that I don't is because I had to round 16.1. So that was not an exact value. And so I always like to use exact values so I know my next answer will be exact. Okay? So it would be fair game to use your S's. But just realize your answer might be slightly off. Okay. So can I go straight into what do I type into the calculator for this? Are we okay with cross multiplying, like we multiply these and then divide by the other?
No, it is never.
You guys are smart. So we're gonna do what?
Oh, if there's a put the multiplication.
Yeah, so 15 times the sine of 107. Make sure you end your parenthesis. Divided by the sine of 35. Just cross multiplying.
25?
25. 25 even. Okay, how do we do? Is that pretty easy? Okay. So that's like 99% of this assignment. There's this other little like scenario. So remember when we were talking about side, angle, and all that other good stuff? Remember those side, angle, sides? And remember I said there's the bad word case, and we have to be careful about the bad word? Here comes the bad word. Okay, you need to write this down. This is what I would write down. I would write everything down that's in the box. Okay, make sure you add in the side angle, or if you want to spell it the other way so you remember, that's fine with me, but don't say it out
The
loud.
one we just learned we can use for any other case except this one.
No, you can still use it. There's just something that happens. So this is an ambiguous case. So these are like this strange scenario that might happen in the world of triangles. Yep. Yeah. So this isn't much more complicated. There's just a little twist.
Usually math books. Yeah, I agree.
Okay, so draw the little triangles. Make sure you write down everything that's in there. Put that in your notes. You're gonna want it. I'll explain it. Write it first, and then I'll explain it. I would draw them. I mean, it's up to you, but I would definitely. Just write it down. I will explain it. Patience. Well, it has to do with triangles. And there's like sides. And there's an H, which is in reference to, what do you think the H might be talking about? Yeah. The height. The swishy arrows? Those are like, oh, I'll explain it. Let me explain. I'll explain the swishy arrows. You don't have to draw the swishy arrows if you don't want to. Oh, just at least draw the triangle. This is my manipulative. Giving you a visual. Oh, really? But I'm using this for a good reason.
Yeah. Oh, I hated it. So we did it last minute. Jeez. Everything was like this response that came out of Google type and went for it. And it was a crash. That's the only reason why I passed that class. Going else to it. You want to class. Yeah, reasonable.
Why did you start?
Ooh, good question. So, did you notice that there happens to be 3 scenarios here? Okay, so in the case that we are given a side-side angle, is everybody with me? Focused? Listening? Okay. We can get 3 scenarios. Okay, we can get 2 triangles, we can get 1 triangle, or we might get no triangle. Okay, so this piece right here is when this 2 triangle scenario happens. Okay, so what does that little piece say? Right. Okay, and the piece that is most important for you to understand, okay, they're never going to give you the height of the triangle. They are going to give you the A's and the B's. Okay, so what I would write down for this scenario is that if your A is less than the B, you could result in 2 triangles. Okay, so let me explain what 2 triangles would look like. Okay, so remember that we're given an angle and 2 sides. Okay, so let's say I'm going to create a triangle off of our table here. Okay, so there's going to be a given angle. So my given angle, let's call it, what would you say that angle looks like? 30 degrees. So that's 30 degrees. That can't change. This length is 4, and my other length is 2. Did I create a triangle? Okay, so you see how this creates 1 triangle. Ready? Pretend that your legs are sturdy. What happened? I created a second triangle using the exact same information. This angle is still 30 degrees, this side is still 4, and this side is still 2. Okay, so that is the 2 triangle scenario. Okay, I'll show you how to solve this. Okay, the other scenario is if this angle is, just say, a little bigger. Let's call this what? This is now 60 degrees. There we go. Let's get it a little bit more obvious. Okay, so 60 degrees. This is 4, this is 2. Ready? What's happening?
It's not reaching the base.
It is too short to reach the base. So therefore, I cannot create a triangle. Okay, so this is going to be a no triangle scenario. Makes sense? Okay, so note to self, when your side that's opposite of your angle is shorter than your adjacent angle, that's when this stuff happens. Okay, opposite side is shorter than your adjacent side. All right, let's do an example of what would happen. How do you do that? Hold on. Almost out of juice here. Okay. Okay. So let's say, I'm going to make this one up. Let's say we're given angle A to be 25 degrees. Side A is going to be 18, and side B is 21. Okay, so they might just throw this information at you without even showing you a picture of a triangle. Okay, so the first thing I'm going to do is I'm going to draw a picture of a triangle. Okay, so here is my 25-degree angle. So that's 25, that's my A. And I'm going to say my side B, so if this is B, that's going to have a length of 21. And then this is going to be 18. Okay, so we'll call this third side C. Sound good? Okay, so let's solve this. Okay, so remember, we're using law of sines. How would you set this up first? Okay, good. Okay, so we know the A's, so we're going to start with the A's. So we're going to have the sine of 25 over 18, and the only other piece of information in the triangle is what? Side B. So the first thing I have to find is I have to find my angle B. So that's going to be equal to the sine of the angle B over 21. Okay, how do I solve for the B? Cross multiply. So can I go straight to the part where I cross multiply? So I'm going to 21 times the sine of 25 and then divide by the 18. Everybody okay with that? So you would agree that this would be the sine of B is going to equal the 21 times the sine of 25 over 18, right? Okay, so type that in your calculator. Tell me what you get. 21 times sine 25 divided by 18. Oh. So 0.5, does that make sense? Is that angle going to be 0.5? It's not 0.5. What do I have to do? The inverse sine. Very good. So remember, I'm looking for an angle. Anytime I'm looking for angle, I have to use inverse. So watch how I type this. I'm going to do second sine. If you use the arrow buttons and just push up, I can highlight the stuff that was already there and just hit enter and it will bring it back down. That way I'm using the exact value as opposed to just typing in 0.49, which is an estimated value. Okay, so if you use that arrow, you'll get an exact answer. Okay, so we should use 29.5 for that degree. Everybody okay with that? So 29.5 degrees. Okay, now what would you do? Find C? How would you find C? Okay, good. So we got two angles. So we're going to do 180 minus 25 minus 29.5. So what'd you get for C? What'd you say? 125? 125.5 degrees. Okay. Now how do I find side C? What am I going to have to do? I have to do a law of sines. Okay, so again, I'm going to start with the original information that I was given. I'm going to use my A's for that first ratio. Okay, always go back to the original because we want to use exact values. So I'm going to do A's over, so I'm looking for side C, so it's going to be the sine of 125.5 over C. Okay, so our little c, we cross multiply that. What are we multiplying? Perfect. 18 times the sine of 125.5 divided by the sine of 25 is 34.7? 34.7. Sweet. Now, this is a scenario where I have two triangles, okay, because my opposite side is shorter. Okay, so if I go back to my little drawing, remember how I pulled that in? This leg ended up going inside like that, okay, creating this red triangle. How could I find that angle? I'm going to call that angle B prime. Well, we don't know the C because the C angle is the blue angle. Well, we can't really do the whole thing, but we're going to eventually have to do the whole thing over again. But right now, I don't have enough information. Okay, because what happens if I type it in, that length is 18, but I still type it in the calculator the same. The calculator is going to pop out 29.5. So, do you see this triangle? If this angle is 29, what's this angle? 29. So how can I get my B prime angle? So it's a flat line, so it's got to be 180. Okay, so that they're supplementary angles. Okay, so to find my B prime, all I'm going to do is do 180 minus 29.5. Okay, so now I have a whole new triangle that I have to solve. Okay, so what's 180 minus 29.5? 150.5, so degrees. Okay, so now going back and solving this whole thing again. This is 21, 18. Okay, what can I find next? My C, good. So how would you find C prime? Good, perfect. So minus the two angles that we have. So 25. So what's 180 minus 150.5 minus 25? It's very small. Maybe not my best example. 4.5, yeah, that's what I got too. Makes a very small one. So my triangle's not drawn to scale. Okay, now how can I find my side C? What do I have to do? Set up a law of sines. Okay, so again, I always go back to the given information. I still am working with my A's for my ratio. The sine of 25 over 18, but now I'm going to use my C prime angle. So the sine of 4.5, yes. over c. Okay, we cross multiply. So what's 18 times the sine of 4.5 divided by the sine of 25? It's also going to be small. No, it's not. Smaller. Is anybody typing it out? You're all staring at me like I want to do it. I bet I can outweigh you. Maybe not. Three? 3 even? 3.3. Okay, so does that make sense? For the two triangle scenario. So when do you got to worry about the two triangle scenario? When the A is less than the B. Okay, on an angle side. No, sorry, I said side angle. Okay. In the case where you have the no triangle, is that what you're going to ask me? Oh. Your A is always the side that's opposite of the given angle. So if they use like P as your angle, then you'll have side P as your opposite of it. So if the side P is smaller than the other side, then that's how you know. Okay? So in the no triangle scenario, I'm not going to do an example of it, just because you set it up exactly the same. So you get to this piece where you cross multiply that sign ratio, and when you type it out on the calculator will pop up an error. Okay, so it'll say, no, you can't do that, and you'll just go, oh, you can't do that because it doesn't create a triangle. So you say no triangle, and you're done. Okay, that makes sense? Okay, that's all I got. Wait, what?
I missed where you got that fourth line.
The fourth line. Which line am I talking? Oh, so that's the scenario of the two triangles. Okay, so remember how this leg can potentially move inward, creating the second triangle. So that's what that fourth line is it's this. And so I drew that on the original triangle because in order for me to find this obtuse angle right down there at the bottom, I have to use the B angle that I found from the original triangle.
We're trying to find two triangles.
Yeah, two triangles. Well, yeah, two triangles from a scenario of 3 pieces of information.
And so when you got the C part, I guess you did it at the beginning, but.
Of the second triangle?
Yeah.
So on the second triangle, the C part is exactly the same as finding the C part on the first triangle, but you have to use the B angle that you find for the second triangle. You see what I mean by that? So like, the only difference between this C and this C is that I'm using this B angle for the first triangle compared to this B angle for the second triangle.
Oh, so they're two different things, they don't really correlate. Besides
Right.
the same.
Exactly,
Same.
yeah. Yeah.
Okay, so I'm trying to compare the two, like, you need that one to finish the other one, when you
Yeah.
don't.
Yeah, once you have this, you don't need any of this, the rest of it.
Okay. Okay.
Okay, here, do you mind grabbing a worksheet for us over there?